Good day, viewers. I welcome you to today's class on my YouTube channel, Dr. Chris Esekaibe channel, where I teach mathematics and statistics topics. Today we shall be looking at time series analysis. Time series analysis is a unique part of statistics that helps in forecasting. Before I go into the topic, let me do a brief introduction of myself. My name is Dr. Chris Esekaibe. I am a chief lecturer and a member of the academic board of one of the most prestigious polytechnics in Nigeria. I live in Nigeria and I work in Nigeria. I hold a doctorate degree in mathematics with distinction, a master's degree in mathematics, and a bachelor's degree in statistics. My area of specialization is numerical analysis. I'm an expert in numerical analysis. I also do a lot. I specialize in data analysis and modeling and statistical analysis. You can consult me with your research work, or if peradventure you are an AI firm or institute or research institute, I can be part of your member of your experts that will be assisting in doing one or two research work, maybe developing algorithm, advanced mathematical and statistical algorithm or models for artificial intelligence. I'll be looking forward to hearing from you. I have written quite a number of books, and I'm a member of the Nigerian Mathematical Society and a member of the Nigerian Statistical Association. Again, here are my contacts, my mobile numbers, and there are also my WhatsApp numbers. You can reach me on these two. The first one is +234 8033021903, while the second number is +234 7066297535. Both numbers are WhatsApp numbers, and my email address is chrisdavid2015@gmail.com. If you are a firm, an AI firm that deals on artificial intelligence, or you are a research institute across the globe, I speak English, I do my work in English, and I write English fluently, you can consult me on these numbers. I will be glad to partner with you or work with your team of experts to develop mathematical and statistical algorithms or models for artificial intelligence. God bless you. I'll be looking forward to hearing from you. Once again, my contacts are on the board. Like I said, today we shall be looking at time series analysis. Time series analysis. If you have, permit me to clean the board, if you have a set of historic data, such historic data can be studied, and after the study, then forecast predictions can be made for future purposes. Now, by definition, what is time series analysis? Time series implies a series of observations on a variable. Time series implies a series of observations. A series of observations on a variable. A series of observations on a variable that is recorded after successive intervals. That is recorded after successive intervals of time. So after successive intervals of time. So this time here must be underlined. So the successive intervals here are usually time interval, equal time interval. The successive intervals are equal time interval. For instance, a series of data can be collected yearly, monthly, weekly, daily, or every 5 years, every 2 years. The interval must be equal. If it is quarterly, monthly, weekly, yearly, as deemed fit by the researcher. So time series implies a series of observations. So there's what we call time series data. On a variable, the variable is defined, and these have been recorded over the years. Some authors call it historic data after successive intervals of time. So these successive intervals of time must be equal. It must be equal, maybe yearly, monthly, weekly, quarterly, every 5 years, every 2 years, and so on and so forth. So that is the definition of time series. So now let us look at objectives of time series. I will take a look, I will just mention 2 major objectives of time series among many others, just 2. The main number 1 objective of time series is to study past behavior, past patterns, or past trend in a set of data. 1. It studies past patterns, or behavior or trend in a set of maybe historic, you can use the word historic data that have been recorded over the years. So time series helps us to study the pattern, the trend, or the behavior in such a set of historic data. The number 2 objective, like I told you, there may be or there are many other objectives, but for this class, I will be focusing on just 2 of them. The number 2 is to make forecasts for the future. It helps, or you can just say to make forecasts or predictions for the future. So these are the 2 major objectives of time series that we shall be looking at. Now, the 3rd one, let me call this number 1, the definition. Then number 2, we have looked at the objectives of time series. Then let's take this number 3, let's call it the components of time series. Time series involves certain components. Number 1 of these components is trend. That is number 1 component of time series. Trend involves a broad, long-term tendencies of either upward or downward movement in the average or mean value of the forecast variable over time. So the trend rate varies over time. So you can call this upward stroke downward movement in time series data. So it involves upward or downward movement. So you want to study the pattern of the movement. For instance, you can take sales or production or sales over the years. You want to study the rate at which the sales is going over the years. Is it increasing? Is it decreasing? Then it will, the trend will reveal that. Then number 2 is cyclical. The cyclical component is also, we have some movements that are cyclical. It's also an upward to downward oscillation of uncertain duration and magnitude about the trend line. So upward to downward, it is also upward stroke downward oscillation that are uncertain. They are uncertain. So these movements are not really certain, and they have their magnitude about the trend line. So permit me to clean the definition as I go to the number 3 component of time series. The number 3 component of time series. So permit me to also claim the objectives. There are just 2 objectives of time series for this particular class. So it is important you wait patiently. There is a lot more to learn. Then number 3 is seasonal. So we have the seasonal movement. It is a special case of movement in time series data as a result of season. So these are seasonal effects. For instance, there are products that are sold in winter. They sell more in winter, and in other weather they may not be sold. There are also some products that are sold in other particular time that may not be sold in other times. So when you see that movement is seasonal, then there are certain factors responsible. Just like the example I gave, for instance, there are clothes that are sold in rainy season. They sell more in rainy season. They don't sell mostly in dry season. So there are businesses, there are factors that are seasonal. There are businesses that are also seasonal. Then the number four is the irregular. This one is irregular movement. So when you talk about irregular movement, an irregular movement is erratic movement in the time series data, and it is caused by short-term, unanticipated, and non-recurring factors. They follow no specific pattern. So these are, you call it erratic movement. They involve short-term, they are unpredictable, e.g. war. For instance, there are countries that may be doing well, but all of a sudden war breaks out. Certain things will be affected in that particular country. So the movements are erratic, they are irregular, and they are short-term movements. They are unanticipated and non-recurring factors. They are caused by non-recurring non-recurring factors. They don't always happen all the time. So they follow no specific pattern. They follow no specific pattern. They are unpredictable. They are also non-recurring factors. So those are the four components of time series. We have trend, we have cyclical movement, seasonal movement. This one caused as a result of specific cases of movement in the time series data as a result of season. So irregular, erratic. So these are the four components of time series. So permit me now to go into another part of time series. Please wait patiently to the end of this video. Once again, subscribe to my YouTube channel, Dr. Chris Isekaibe, and share my videos on your social media platform. And as you do, God will bless you. Now, as we progress, we are looking at time series decomposition model. Time series decomposition models. Time series decomposition models. Analysis of time series involves two major steps. There are two major steps involved in the analysis of time series. So steps involved. Step number one is identifying the various factors, so forces which produce the variations. So identify the factors, stroke forces that produce the variations in the time series data. That's the first thing you need to do. You need to first of all identify the various factors or forces which produce the variations in the time series data. Then step number two, you have to analyze and measure the effect of these factors separately. Analyze and measure the effects of these factors separately. And independently. So when you do this, you are already on your way to getting the problem solved. So you analyze and measure the effects of these factors separately and independently. The purpose of the decomposition model is to break a time series data into components. No, you know we have four components. The first one is trend, and trend is written as capital letter T. The next one is cyclical, and it's written as capital letter C. And the next one is seasonal, and it's written as capital letter S. And the last one is irregularity, and it's written as capital letter Y. So there are many models for analyzing time series data. Hence, we shall be looking at just two models. So the models, now time series models, still talking about the decomposition models in time series. So the first model is the multiplicative model. Multiplicative model. This one, the forecast or the estimate variable is y, is given as y hat. So since it's multiplicative, these 4 components will be multiplied. So the trend, it will be t times the cyclical variation times x for the seasonal variation, then times I for the irregular variation. So that is the forecast for the multiplicative model. So y here is an estimate. That is the forecast variable. Then the number 2 model is, permit me to claim this part. The number 2 model is the additive model. The number 2 model is the additive model. So we have number 2, the additive model. This simply means it is assumed that the components can be estimated by adding them together. So that it means each of these components can be estimated, then they are now added together. So the forecast variable y will now be the addition of these components. We have the trend plus the cyclical variation plus the seasonal, then plus the irregular. So this is the additive model. Hence, in real life time series data, this assumption does not hold good. It doesn't hold. In real life, it looks very, very impossible to estimate each of these before they can be added together. But this model still has to be done. It has to be calculated. If they can be estimated, if each of these components, the trend, the cyclical, and the seasonal, and the irregularity components can be estimated, then the additive model can hold. But in real life situation, it proves almost impossible. So this takes us to the next part of the topic. How do we measure trend in time series? How do we measure the movement in time series? So that is what we are going to be looking now. Measurement of trends, measurement of circular trend or patterns of movement in time series data. There are so many methods we can use, but for the sake of this class, let's look at it. Measurement of trend stroke movement in time series data. In time series, let's call it like that. So how do we measure trend, circular trend in time series? We have 3 methods we shall be looking at in this class. The number 1 method is the freehand curve method. Number 1 is the freehand curve method. The number 2, we shall be looking at the method of averages. Method of averages. And number 3, we shall be looking at method of least squares. So now we shall be taking them one after the other. Let's start with the first one, the free hand method. This one is very simple. When a time series data is given, all you just need to do is to sketch a curve or draw a curve smoothly through the data values. I'll give an example. If I have an example, I say fit a trend line to the following data. To the following data using a freehand method. Using a freehand method. When you have this, it is as simple as ABCD. You have the data here, you have the year, then you have sales. So we have it from 2020, 2021, 2022, 2023, and 2024, and the values are 35, 40, 38, 45, and 50. Now this is very simple to implement. You just draw a simple graph and you sketch the curve. So permit me to clean this part of the board so that we can quickly see how we can go ahead to do this. How we can go ahead to do this. So the next thing we need to do now is to sketch this. Now we have the data. So I can come and sketch this. Here the sales will be on the y-axis, y the year will be. Here you have your 2020, 2021, 2022, 2023, 2024, and so on and so forth. So the data is from 2020 to 2024, and since the data is starting from 35, we can just take it this way. This will be 35, this will be 40, this will be 45, and we'll take it here like this. This will be 50. So these are the sales, and these are the years. So it's as simple as that. So for the first year, 2020, we have 35. So you come up here, you mark. Then for year 2021, we have 40. You take it up and just sketching, you mark. Then for 2022, we have 38. You come here, 38 is below 40. Then you mark. Then for 2023, we have 45. You take it up, 45 is here, we mark. Then for 2024 is 50. You take it up, that's the highest, then you mark. So we can now sketch like this, it goes like this, comes down, it goes up again, and it goes up like that. So you can see how we can use the freehand to sketch. The limitation of this freehand method is that the trend line depends on personal judgment. Hence, it is highly subjective. It is highly subjective. And again, it is time consuming and it makes prediction very difficult. It makes prediction and forecasting very, very difficult. So this is how we use the freehand method to solve or to study trend or movement in the time series data. You can see if you are to inspect the data visually, from year 2020 is 35, then it increased to 40, now decreased again to 38 in 2022. It now moved up again to 45 in 2023, and also it moved to, this movement is not too steady. You can see that movement, it rose, came down, then it now had a consistent increase. So this is how we use this freehand method. So it is limited because it is based on personal judgment. Now we want to look at another method called the method of averages. Averages, taking averages. We want to see how we can use the method of averages to study trend or movement. And so for the other one, we call it the method, that's number 2 now, method of averages, or you can also call it the smoothing method. Smoothing method. So now, if you are to use this method, it involves 3 smoothing methods. There are 3 smoothing methods here. 3 smoothing methods. Number 1 of these 3 smoothing methods is, we call it the moving averages. Then number 2, we call it the weighted moving averages. And number 3, we call it the semi-averages. So these semi-averages, the data are divided into 2 parts. Now, the essence of this is to smoothing out irregular pattern in the data set, then use it to forecast. If there are irregular patterns in the data set, one major way of smoothing it is using the method of averages, or that's why they are called smoothing method. So if there are irregular patterns, it can be smoothing using the smoothing method, the method of averages. So we are going to take an example and see how we can get moving averages when a particular set of data is given. So permit me to clean this. We want to get an example. An improvement of the data we have before. If you have the year, then you have the sales, the Y are the sales. So you have it like this. You have it from 2017, 2018, 2019, 2020, 2021, 2022, 2023, 2024. So if you have this and you now have the sales to be 30, 32, 33, 35, 40, 38, 45, and 50. Now, if you are told to get a 3-point moving average of this set of data, 3-point moving average. So it is as simple as that. You just come here, 3-point moving total. That's what you start with. You will start with the moving total. That means you will be taking it, if you say 3 points, you are taking it 3, 3. If they say 2 points, you are taking it 2, 2. If they say 4 points, you are taking it 4, 4. So you are taking 3 points moving. First of all, before you take the average, you take the total. So if I say 30 plus 32 plus 33, that will give me 95. Because that is the first 3, 1, 2, 3, I will put it at the middle of the 3, 95. Then the next one I will take for the next one, I'm done with this first set, 30, 32, 33. The sum of it is 95. Then the next one will be 32 plus 33 plus 35. That will be 100. Then the next one will be 33 plus 35 plus 40. That will be 108. Then the next one will be 35 plus 40 plus 38. That will be 113. The next one will be 40 plus 38 plus 45. It will be 123. Then the last one will be 38 plus 45 plus 50, and that will be 133. So this is how to get the 3-point moving total. I come again in explanation. Then you will take them, if they say 2 points, you will just take them 2, 2. You take them in 2s. If they say 3 points, you take them in 3s. If they say 4 points, you take them in 4. So this one now is 30 plus 32 plus 33. That is 95. Then the next one is 32 plus 33 plus 35. That is 100. Then you keep going like that, taking them 3 after 3. So before you now get to the last, you get to the last value there. So the next one, we are going to look at the 3-year moving average. So we are looking at the 3-year moving average. That is what we are going to do next. The 3-year moving average. It means, since it's 3 years, you are going to be dividing each by 2. If you say 95 by 3, since it's 3 years, you are dividing each by 3. 95 divided by 3 is 31.67. 31.67. Then 100 divided by 3 is 33.33. Then the next one, 108 divided by 3 is 36. 113 divided by 3 is 37.67. Then 123 divided by 3 is 41. Then 133 divided by 3 is 44.33. So this is what you have. So you can see that we have been able to create a 3-year moving averages for this data set. And now, if you come to plot it, you will see that there is a smoothing. A smoothing has already taken place. Let me explain. Look at the data. It was increasing from 2017 until it got to 2021. It now dropped from 40 to in 2022 to the 38. So, but if you look at the moving average, it has been able to smoothen the data set. It has been able to smoothen it. If you look at this now, this is 31.67. The next one is 33.33. The next one is 36. Then the next one is 37.67 and 41, and the next one is 44.33. Now, if you can plot this in the graph and see the difference, permit me to go ahead. Now we have the years from 2017 to 2024. So permit me, I will put it this way: 2017, 2018, 2019, 2020, 2021, 2022, 2023, 2024. Permit me to put it like that. So the x-axis will definitely take the years. Then, of course, the y-axis will take the sales. So the sales will be here. So permit me, the smallest value there is 30. So I will start from the smallest there, which is 30. Then the next one will be 35. Then this will be 40. This will be 45. And this will be 50. So this is how we are going to sketch it. Now I want to first of all sketch for the time series data, the sales. You can see at the year 2021, between 2021 and 2022 there was a decrease, but the moving average, that's why they are called smoothing. It has been able to smoothen it, and you can see a steady increase in the 3-year moving average. So the averages have smoothened it, but now let's go ahead and see what we have. In year 2017 is 30 on the dot, so you put it here. 2018 is 32, it's a bit up. Then 2019 is 33, it's also a bit up. Then 2020 is 35, 35 is here. Then 2021 is 40, 2021 is 40 here. Then 2022 is 38, it dropped a little, so 38 will be somewhere here. Then 2023 is 45, 45 is here. Then 2024 is 50, that is the highest, so it goes up here. So if you have to sketch, it goes like this, like this, like this, like this. Then it comes down, then it goes up, and it also goes up. So you can see the pattern or the movement or the trend in the sales that we have. Now, permit me to do the one for the moving averages. The first one here, I will put it under 2018, is 31. So 31, let me put 31, 18, 31 will be here. Then roughly 32, 33.33 for 2019, 23.3 down will also be here. Then the next one, 36, 36 will be a bit above. Then 37 will also be a bit above. 36 will be here. 37 will also be a bit above. 37 is a bit above. Then 41 point for 2022. 41 will be somewhere here. Then for 2023 you have 44. So 2023 44 will be somewhere here. So if you sketch, you see the pattern. You see the pattern. There is no decrease because the moving averages have been able to smoothen this particular variation here. So that is why the moving averages are called the smoothing method. They help to smoothen the time series data. So you can see there is like a steady increase. You will now see it from the data. So this particular downward movement between 2021 and 2022 has been explained by the moving averages. I hope we have learned one or two things. So with the help of this, we can also draw a trend line and use it to forecast. So this will now lead us to the third type of measurement of trend, and that is the methods of least squares. The methods of least squares. So permit me to clean this part and this particular heading here, the method of least squares, and the methods of least squares. Also, let me clean this data part of it. The data, we are still going to use the data to solve, to analyze, but let's leave the data on the board because we are still going to make use of it. Now, number 3 is the method of least squares. Now, this method involves the fitting of a trend line to the series of historic data. So you fix or you fit a trend line, and then you use the trend line to project into the future for a medium long-term forecast. So the first part we shall be looking at today, though the trend line may be linear and it may be non-linear. So for today, for the sake of this class today, we shall be looking at linear trend line. So that's the one we are looking at today. So if we have linear trend line, that means there's also room for non-linear trend line. So the model will now be A plus BX. This is the model that we shall be looking at. Of course, it's an estimate for Y. Our A means the intercept. A is intercept, while B represents the slope. It is B that determines the nature of the value of this particular forecast. B as the slope determines the nature, and again, from this model, we can use the method of least square. I have a short way of getting the normal equations. The normal equations are gotten this way. Now, first of all, I will run a sum through this. Our summation y is equals to NA. N means the number of observations plus B summation x. Then the second one, I will multiply it in the independent variable. I use it to multiply this. This will now be summation xy is equal to A summation x plus B summation x squared. So that is what you have there. This is the normal equation. So in a situation where we decide to code the data, the time series data can be coded. For instance, when n, if n is an odd number, for instance, if n is odd, we can code it. For instance, if I have the year to be, I will give an example. If I have the year to be 2015, 2016, 2017, 2018, 1, 2, 3, 4, 2019, for instance, I can code it to have the time. Then I can start, since I can put the middle, since it is odd, if n is odd, 1, 2, 3, 4, 5. If n is odd in number, the middle one you put 0. There will be a middle year. So you just start from here minus 1, minus 2. It should now be plus 1, plus 2. So the sum of x, so you now have from here, okay, let's call it x. Then the sum of x will now be 0. So if n is odd, you can code the data to get the sum of x to be 0. But when n is even, you can use this data directly. So when n is odd, you are also permitted to code the data so that your summation x, so that you can code when, or you can say if n is odd, and you can code the data and making summation x to be equal to 0. And here, if summation x is 0, it simply means that this part will be 0, so hence summation y will be equal to this summation x, b will be 0, 0 times b will be 0, so you have your NA, your summation y will be NA, and your summation xy, if this one is 0, a times 0 will be 0, will now be equal to b summation x squared. So that is when the data, you have n to be odd, a number, you can code it. But here, our n is not odd. If you count the number of years we have, 1, 2, 3, 4, 5, 6, 7, 8. So here, n is even. So we may not need to code the data, and when that means these normal equations can be used directly. So when n is even, you use this formula directly, then you will have your a to be equal to, y bar minus b x bar, and your b will now be equal to summation xy minus n x bar y bar all over summation x squared minus summation, or minus n x bar squared. So when n is even, you can use these two formulae to get your a and your b. So for our case, our n is even, so we are going to use this particular formula. So that means we need to get summation xy, summation x squared, and so on and so forth. We also need to get the mean of x and the mean of y. So I hope this is taken note of. So let us go ahead now and calculate what we need to calculate. Permit me to rub the board. I hope you are following the class, please. You still have many important parts to go. Try and be patient as we take this video to the end. So since we have that, we have our sales and our y, so we need to get our time period. Our time period is called P and is denoted as X. So to get this, you are going to run the here from 1, 2, 3, 4, 5, 6, 7, 8. There will not be need to code the data. So now that means we will need another code for x squared. So our x squared will be 1 square is 1, 2 square is 4, 9, 16, 25, 36, 49. 8 square will be 64. Then now, after x square, we will need to get our xy. Our xy will be this. That means this times this is 30. Then 32 times 2 is 64. 3 times this, 99. 99, 140, then 40 times 5, 200, 38 times 6, 228, then 45 times 7, 315, then 50 times 8, that is 400. So we need to sum up the sum of the sales is the sum of y is 303 and the sum of x is 36. You add it up. Then the sum of x squared is 204. Then the sum of xy is 1476. 1476. So that is what you have there. So permit me to come now, since we need to get our x bar and our y bar. Our x bar is equal to summation x all over n. Summation x here is 36. 36 all over 8. Now 36 divided by 8 is 4.5. Then our y bar is equal to summation y all over n. And our summation y, which is the sales, is 303 all over 8. And that is equal to 303 over 8 is 37.875. 37.875. So this one is 4.5. So now we have that. We can now proceed to get our b. Remember, our b is equal to summation xy minus n x bar y bar all over summation x squared minus n x bar all squared. So when you carry that out, our summation xy is 1476. Then minus n is 8 into x bar is 4.5. While this one is 30, okay, is 30. Okay, permit me to write it down here. Summation x, y is, so b is equal to 1476 minus n is 8 into x bar is 4.5. Then y bar is 37.875. Then all over summation x squared is 204. 204 minus n is 8 into, what is our x bar? Our x bar is 4.5. 4.5 squared. So having that, if you carry out the arithmetic up there, you are going to have 112.5. You are going to have 112.5. Okay, permit me to write it down, there's no space. B will be equal to 112.5 all over. You carry the arithmetic 204 minus this, you are going to get 42. So our B will be equal to, when you divide that, you are going to have 2.68. Always take it in two decimal places. 2.68. So our B, we have gotten B to be 2.68. Then to get our A, remember our A is equal to y bar minus bx bar. So our y bar again is 37.875 minus B is 2.68 into x bar 4.5. So you have that into A. So when you carry out that arithmetic, you are going to have your A to be 25.82. So our A will be equal to 25.82. So you can see now we have been able to get the model. So this model, permit me to clean this part of the board. So our model y hat is equal to a plus bx becomes y hat is equal to, what is our a? Our a is 25.82 plus our b is 2.68x. So that will now become our model. So we have gotten a very good model. Then you can see that from there we can begin to use that model to predict for year 2025, 2026, and so on and so forth. We can use it to predict for year 2025, for year 2026, and so on and so forth. So if I want to use this to predict, for instance, for year 2025, if I want to use to predict for year 2025, I will have for year 2025, when for 2025, that means our x will be equal to what? 2024, our x is 8. So it starts from 1, 2 down to 8. So year 2025, our x will be equal to 9. So forecasting y part will be equal to 25.82 plus 2.68 into 9. So our y hat for year 2025, the estimated value of y for year 2025 will be 49.94. So it will be equal to 49.94. So you can see how we can use this time series model to forecast, and you can also go ahead if you feel like testing for the goodness of fit of the model. Of course, you can go ahead and test for the goodness of fit of the model. So this is how far we have been able to go. We have been able to get a model, and we have been able to see how we can use the model to forecast. The model is a good model. It has been tested. It's a good model, and we have been able to predict. If you want to predict further for year 2026, let's predict for year 2026. For year 2026, for 2026, our x will be equal to 10. So we'll now say y at will now be equal to 25.82 plus 2.68 into 10. So our y hat for 2026 will now be, it's as simple as ABCD. You can come here, you have 25.82 plus 26.8. You're going to have 2, 6, carry on, then your point. So you're going to have 52.62. So you're going to have 52.62. So that is the sales will be approximately 53. It will be approximately 53. Then the sales for year 2025 is approximately 50. That for 2024 is 50. So it's also almost approximately equal with that of 2025. But for year 2026, it has improved to 53. So you can see how we can use these models to forecast. How we can use them to forecast. So I believe you have learned something today. Time series is a very vital part of statistics. It enables us to study trends and patterns and movement over the years. Data can be gotten over the past 80 years, 100 years, 500 years. When the data are analyzed, you can get a model using the method of least square regression model. Then you can now begin to use it to forecast, to predict. So the two major objectives of time series is to study the patterns and the trend or movement in the historic data. You study the pattern, the movement in that historic data. When you now study that pattern, then you now use the data to get a trend, a model. Some authors call it trend line. It can be linear, it can be non-linear. Today we looked at a linear model. So you now get, after you have studied the trend, the pattern over the years, in that historic data, you now study the pattern, the behavior in the data, then you now get a trend, that a trend line or an equation or a model that you can now use to forecast into the future. These are the advantages of time series. It helps you to forecast. It helps you to predict after you have studied a particular set of historic data over the years. Once again, beloved, My name is Dr. Chris Esekaibe. I'm a chief lecturer in one of the most prestigious polytechnics in Nigeria. I hold a doctorate degree in mathematics, a master's degree in mathematics, and a BSc in statistics. I'm a member of the Nigerian Mathematical Society and a member of the Nigerian Statistical Association. If you are an artificial intelligence firm across the globe, you have research, or you are a research institute, you want me to be part of your research team, I will be glad to do that. My contacts were displayed at the beginning of this video. See my contact numbers, my WhatsApp numbers are there, my email address is there. Please contact me so that we can work together as a team to develop advanced mathematical and statistical models or algorithms for artificial intelligence and also machine learning. I will be like to be part of your research team to do that. So please subscribe to my YouTube channel, Dr. Chris Esekaibe, and click on the notification button so that anytime I upload a model or upload a video, you will have a notification. Share the videos, be part of those sharing knowledge across the globe. Once again, the essence of this YouTube channel is to share knowledge across the globe. See you in my next video. Enjoy the rest of the day. God bless you. Bye.